Hello. These lectures are an introduction to Bitcoin, the world's first and best-known cryptocurrency. As we'll see, there are many elegant and clever ideas behind Bitcoin, although all these ideas are conceptually quite simple. In particular, the cryptography behind Bitcoin is standardized and well understood. The SHA-256 hash function is used to generate so-called proof of work, whereas the ECDSA signature scheme is used to sign transactions, which is a transferring of coins from one user to another. Despite the simplicity of these ideas, the Bitcoin protocol itself is rather complicated. And the fact that Bitcoin works today as a functioning cryptocurrency with a market cap that has exceeded $1 trillion US is truly remarkable. These lectures have been divided into 4 parts: an introduction to Bitcoin and blockchains, cryptographic ingredients, Bitcoin explained, and the future of cryptocurrencies. The first part will be an introduction to Bitcoin, emphasizing the most important contribution of Bitcoin, which is the implementation of a public decentralized storage system in the form of a blockchain. The second part will give high-level summaries of the main cryptographic ingredients of Bitcoin, the ECDSA signature scheme, and the SHA-256 hash function. The third part will be a detailed description of the Bitcoin protocol. In the fourth and last part, we'll discuss some of the challenges that Bitcoin and other cryptocurrencies face. I'll take a quick look at Ethereum, the second largest cryptocurrency by market cap. And I'll briefly mention some other cryptocurrency and blockchain projects. Before we begin exploring Bitcoin, let's reflect on some of the properties of paper cash. By a coin, I mean either a paper bill or a metal coin. These coins are issued by the Bank of Canada in accordance with some monetary policy. For example, the Bank of Canada might print more cash to stimulate the economy, but at the risk of increasing inflation, and so on. Suppose now that Alice wishes to pay Bob for some goods or services. Alice can give Bob her coin, and Bob can examine the coin to verify that the coin is valid. In other words, not a forgery. Bob is not concerned with Alice double spending the coin, because coins are physical objects that cannot be easily duplicated. When Alice gives Bob the coin, she doesn't need to identify herself to Bob, unless a particular transaction requires identification. Nor does Alice need to explain to Bob where she got the coin from. So paper cash gives Alice some degree of privacy. Namely, Alice has payer anonymity, she does not need to identify herself during payment, and she has payment untraceability. So Bob cannot trace Alice's coin back to Alice, assuming that Alice did not identify herself during the payment. Here are some of the features of paper cash. Paper cash is recognizable by the general population as legal tender. It's portable, it's transferable, so cash can be spent without the involvement of a bank, financial network, or government. It is divisible, so one can make change. And as already mentioned, it is unforgeable, anonymous, and untraceable. You can check that many of these features are not available with electronic payment systems such as credit cards. I'll next present some features of Bitcoin while deferring a detailed technical description of how Bitcoin works to the next 2 videos. Bitcoin is an electronic cash system invented by Satoshi Nakamoto in 2008. The first remarkable property of Bitcoin is that its inventor is anonymous. The true identity of Satoshi Nakamoto is not known today. The second remarkable property of Bitcoin is that it is decentralized. In other words, not under the control or operation of any central authority, such as a bank or a government. The decentralized feature begs some natural questions. Who creates Bitcoins? And the answer, as we'll see, is that anyone can create Bitcoins. Well, if anyone can create Bitcoins, how can the creation of Bitcoins be regulated without using a central authority that everybody must trust? And the answer is the creation of coins is self-regulating, as we shall see. Since a Bitcoin is a digital asset and not a physical object, how can the recipient of a Bitcoin ensure that the Bitcoin has not already been spent? And the answer is all Bitcoin transactions are stored in a public ledger called a blockchain. Anyone can examine the blockchain to confirm that a coin is valid and hasn't already been spent. The third appealing feature of Bitcoin is that anyone can use it. You can download a wallet from websites such as bitcoin.org and then obtain Bitcoins by a process called mining, or from an exchange such as Coinbase or Kraken. I'll note that Bitcoin provides a degree of payer anonymity and payment untraceability, but these are not primary goals of Bitcoin. The first Bitcoins were generated by Satoshi Nakamoto on the 3rd of January 2009. So Bitcoin has been functioning for more than 12 years. The basic unit of currency is 1 Bitcoin, which can be divided into 100 million pieces, each called a Satoshi. As I mentioned earlier, Bitcoins can be mined by anyone. The rate at which they are mined is self-regulated by the system. Our Bitcoins are generated every 10 minutes or so. Initially, R was 50. This rate was halved in 2012 to 25, and again in 2016 to 12.5. And most recently in 2020, the rate was lowered to 6.25. This rate will be halved over time until the year 2140, when a total of 21 million Bitcoins will have been generated. As of September of this year, about 18.8 million Bitcoins have already been mined. One drawback of Bitcoin is that its market value has fluctuated wildly. Here's some sample Bitcoin values from May 2010 to September 2021. The first valuation of Bitcoin occurred in May 2010, when someone bought 2 pizzas using 10,000 Bitcoins. This purchase was made as a proof of concept. At today's valuation, these 10,000 Bitcoins would be worth approximately $400 million US. As of September of this year, the market value of a Bitcoin was approximately $45,000 US, giving Bitcoin a market cap of roughly $800 billion, which is truly astonishing. Why would anyone use Bitcoin? Well, first, it's decentralized, so not under the control of any government, bank, credit card company, or financial organization. This is especially appealing to people who mistrust governments and banks, including anarchists and libertarians. Secondly, anyone can use Bitcoin even if they don't have a credit history. Thirdly, Bitcoin's monetary policy is fixed and public, unlike, say, ordinary cash, whose value can change based on government monetary policy. This has made Bitcoin attractive as an asset for storing value, for example, in countries such as Venezuela that have experienced hyperinflation. Fourthly, transaction fees in Bitcoin are low. However, these are increasing. Fifthly, transactions are irreversible, unlike, say, credit card transactions, and this is favored by online merchants. Sixthly, transactions can be anonymous if the user exercises some care. I should emphasize that there are also many reasons not to use Bitcoin, but I won't dwell on these for now. At a high level, the most important contribution of Bitcoin is the implementation of a public, decentralized storage system, also known as a distributed ledger, in the form of a blockchain. By blockchain, I mean a sequence of data organized in blocks with the following properties. The blockchain is public, so the data is readable by everyone. It has consensus, so the data is agreeable by everyone. The blockchain has liveliness, so anyone can write data to the blockchain at any time. And it is persistent, which means the data is changeable by no one. You can think of a blockchain as a database that is readable and writable by everyone. However, the persistence property rules out the possibility of the database being stored and maintained by a single party, such as Dropbox, Amazon, or Google, since such a party could modify some of the existing data. So the persistence property imposes the decentralization requirement on a blockchain. Blockchains have many potential applications beyond cryptocurrencies. These will be briefly mentioned in the last video. I'll note that blockchains are very complicated to design and implement, and should not be used when a trusted entity is available. In that event, the trusted entity could simply store the data in a database. I'll next summarize how Bitcoin works at a high level. An entity Alice can spend a coin by giving it to an entity Bob. To spend the coin, Alice signs a message of the form, "Alice hereby gives 1 Bitcoin to Bob." This message is called a transaction. The Bitcoin blockchain stores all previous transactions. The blockchain is replicated and stored across many parties. Bob broadcasts the message on the Bitcoin network. Parties called miners use the data on the blockchain to verify that the transaction is valid. In other words, that Alice indeed possesses the Bitcoin and that she hasn't already spent it. A miner compiles a block consisting of all valid transactions received in the previous 10 minutes or so, and adds the block to the blockchain. To add a block, miners have to solve a cryptographic challenge that requires a large amount of computation. This process is called mining. The first miner to solve the challenge is able to append the block to the blockchain. The miner receives some Bitcoins as a reward. Rewards incentivize entities to mine and to do their job properly. In Bitcoin, transactions are signed using the elliptic curve digital signature algorithm, ECDSA. Solving a cryptographic challenge requires many applications of the SHA-256 hash function. Before we dive into the details of how Bitcoin works, let me introduce the SHA-256 hash function and the ECDSA signature scheme. I'll do this in the next video.